calculus anti-differentiation problems. I'm going to do two in this video here. We've got problems 12 and 18 in this set. And we have number 12. I'm going to rewrite 12 in what I call calculus friendly form. First of all, this x to the 3/4 power, what you want to have is for calculus friendly form, your polynomials in rational form of exponents. You have minus, minus 1 over x to the 3/4 power. Well, that's going to be x to the negative 3/4 power. Yeah. Okay, so now we have our calculus friendly form. We'll continue below. What we have is we have x to the 3/4 plus 1, bump up and divide, and that's going to be to the 7/4 power. And then we're going to divide by 7/4. Well, it so happens that dividing by a fraction is the same as multiplying by its reciprocal. That's something we can really use a lot in integrating. So instead of dividing by 7/4, we can go ahead and multiply by its reciprocal 4/7. And then this next one here, we have minus x to the, let me read myself a little more, minus x to the, what's negative 3/4 plus 1. Well, it's going to be 1/4. And then we divide by 1/4. And dividing by 1/4 is the same as multiplying by 4. And then we have our constant integration c. And I don't see that we can make this thing any simpler than we have right here. Let's do that picture. Problem 12. Next, go on to 18. And here's 18. We have the integral of quantity 3x minus 2 squared over square root of x. So what I'm going to do is expand this binomial in the numerator to get what we have is 3x squared, which is what we know, x squared. And then we have 2 times the first and the last. Well, negative 2 times 3x is negative 6x times 2 is going to be minus 12x. And then we have plus 2 squared, which is 4. And we're dividing all this by square root of x. Or we'll rewrite square root of x as x to the 1/2 power. And so all this becomes dx. Okay, so there, that's what we have. So that's our setup. And I'm just going to continue down below. When we divide 9x squared by x to the 1/2 power, we subtract exponents. So what we get here is 9x to the 2 minus 1/2 is 3/2. Then we have minus 12. We have x divided by x to the 1/2 power is going to be x to the 1/2 power. Okay, and finally, we have plus 4. And 4 divided by x to the 1/2 power is 4x to the negative 1/2 power. And then all this dx. And so now we have our calculus-friendly form to work with. And so we're going to have 9x to the 3/2 plus 1 is going to be 5/2. And then dividing by 5/2 is the same as multiplying by 2/5. Okay, and then this next one we have is minus 12. And we have x to the 1/2 plus 1 is going to be to the 3/2. And dividing by 3/2 is the same as multiplying by 2/3. Okay, and the last one we have is plus 4. We have x, and what is 1? Negative 1/2 plus 1, that's going to be 1/2. And then if we divide by 1/2, it's the same as multiplying by 2. And we add our constant of integration c. So now it's just a matter of simplification. So we have 2/5 of 9 is going to be 18/5. My pen is a little bit glitchy here. So we have 18/5 x to the 5/2. Okay, and then we have minus, we have 12 times 2 is 24, divided by 3 is 8. So we have minus 8x to the 3/2 power. And then finally we have plus 8x to the 1/2 power. And we can write this as a square root of x if we want to. I'll just leave this as x to the 1/2 power plus c. And we can rewrite these other things if we want to. And, I'm just going to write all these in radical form. So we have 18/5. Pen is using its memory somehow. So square root of 2 to the 5th power. And then we have minus 8. We have square root of x, which is the 1/2 power to the 3rd. And then we have plus 8 square root of x plus c. Yeah, this pen is pretty glitchy. So anyway, that's number 18 completed. I hope this has been helpful to you. Good luck, and thanks for being here.